There we go. I think we're just waiting for a couple more people. Shall we start with quick introductions? So I'm Hannah, I work at JEOL UK in the sales department. If you have any questions throughout the webinar, just feel free to pop them in the chat and we'll get back to you. Damien, do you want to go next?
Yeah, sure. Hi, I'm Damien McGrowther. I'm an application specialist at JEOL UK, mainly on high-end TEM and STEM for materials science, but also I work in life science projects with cryo-FIB. Bart.
Okay, hello everyone. My name is Bart Marzek. I am an application specialist with JEOL Europe SAS. I'm particularly interested in biological TEM, cryo-EM in particular, and today I will tell you a little bit about accessing electron microscopy facilities remotely. Thank you.
Sarah?
I'm Sarah Tannand and I'm a project manager for Instruct ERIC.
And lastly, Ayub, and then do you want to start your introduction?
Hello everyone, my name is Ayub and I'm a European project manager working for Euro-BioImaging and Instruct. And should we start or we wait for a couple more minutes for the others to join?
I think maybe one more minute and then we can get started. Shall we get started?
Yeah, I think we can start, Hannah. And actually, I would like to thank everyone for having the time to join us today for this very exciting workshop on remote access to electron microscopy. And before to start, we would like to give a brief introduction to the eRImote project, which is actually sponsoring our workshop today, and to Euro-BioImaging. And then I will hand over to Sarah and Hannah, who will introduce you to Instruct and Jeol, who I would like to thank for the collaborative effort in organizing this event. So here you can have a quick look to our agenda for today. And we can start with the eRImote project. So eRImote is actually the first European funded project that considers a solution for digital and remote service provision across research infrastructure domain, and with an objective to build a foundation of knowledge based on transferable practices and the new developments that will try to improve the accessibility and resilience of research infrastructures. And as you can see on the screen, one of the objectives of the eRImote project is actually to create a public knowledge database, including different aspects related to remote access provision, which actually we did in the project. It's called the Online Information Platform. And the other project is actually to provide the European Commission and the scientific community in Europe with a set of recommendations on how to actually foster further developing remote and digital infrastructure processes. And this is something that has already been published as a green paper. And I will try to put the links in the chat. We have been trying to do this through organizing several workshops, trying to identify the challenges and solutions in remote training, remote operations, and policy and funding. And we have been also organizing a series of cross-domain experts group meetings on different thematics, but always related to remote access, such as researcher experience, data training, remote instrument control, and international access. And all documents and recordings that were generated from these events are openly available on the eRImote online information platform. I will also put the link in the chat. Here you can see the map of partners directly involved in the eRImote project. So the consortium involves highly recognized European research infrastructures that basically covers the different S3 domains like life science, environmental sciences, physical sciences, and engineering, and also social and cultural sciences. Now, Euro-BioImaging, which is also a partner in the eRImote project, so it's the European research infrastructure for biological and biomedical imaging. And we are a publicly funded non-for-profit organization. We are distributed across 18 countries and the EMBL in Heidelberg, Germany, where I'm actually based. And we have 41 nodes across Europe with 237 sites, offering open access to more than 120 individual cutting-edge imaging technologies that spans from the very small atomic force microscopy to really clinical and preclinical imaging for human. And we also, besides providing access to instrumentation, we provide access to data and image analysis services. As you can see here, we have the list of our nodes that actually provide access to electron microscopy services. And as you can see, they are really distributed across Europe. And you can see on your right that we offer access to a really wide and broad service portfolio when it comes to electron microscopy. We also have an industry board at Euro-BioImaging because we really appreciate and want to work with industry partners to organize similar events and to reach out to the community of users. And through the industry board, we want also to respond to our node and facility staff needs when it comes to collaboration, training, and technology developments. And now I leave the floor to Sarah, who will introduce you to Instruct. Sarah, please.
Thank you. So on behalf of Instruct, welcome to this EM workshop today. I'm Sarah Townend and I work for Instruct as a project manager. And we are the leading structural biology research infrastructure, providing access to high-end technologies and training to the research community. Can I have my next slide, please? So our service catalogue comprises of more than 80 different services, spanning from sample preparation, like protein production, to biomolecular analysis like mass spec, and 3D characterization like X-ray and EM. And we offer these services in our facilities all across Europe. Can I have my next slide, please? So as this is a cryo-EM workshop, I wanted to highlight this service in particular. So our EM services are one of our most popular amongst our community, with about 30 to 40% of our access provision being for EM. And we offer services to that cover the complete EM pipeline, so from sample preparation for both single particle and tomography, cryo-clem screening, high-end data collection, and finally image data processing. So these EM services are offered all over Europe, and they can be both in-person and remote visits. Thank you very much for listening, and I will now hand over to Hannah.
I believe Damien will actually give the introduction, but thank you.
Oh, sorry.
That's all right, it's no problem. Yeah, so as mentioned, I'm Damien McGrowther from JEOL UK, for those of you that just joined since we did an initial round of introductions. Next up is going to be Bart Marzek, my very expert colleague who has engineered a number of software solutions for working remotely on our microscopes. So I just wanted to say that Bart's going to cover quite a lot of ground today. So we're going to give you the opportunity for some questions just before the coffee break, and then there will be another opportunity at the end of the session to ask any questions that come from right across the session. To ask questions, you can either put them in the questions box of your GoToWebinar software, or you can wait to the question session and raise your hand using the little raised hand symbol, and then I will be able to allow you to come on mic and ask a question to Bart directly as well. So either way is fine for asking questions. So hopefully with that sorted out now, I can hand over to Bart and he can give his presentation. I believe the first one is about remote microscopy with existing tools.
Yes, indeed. Thank you, Damien. Thank you all for the kind introduction. Indeed, I would like to start this webinar by discussing the currently existing technologies that allow us to control electron microscopy facilities remotely. Maybe let me share my presentation with everyone. Here we go. I can only hope that I can minimize this little thingy. Yep, hopefully I can. Goodie. Right. So why are we doing this, right? Why do we discuss remote access in the electron microscopy context? Let me share with you a story from about 2.5 years ago. That was the time when we were all locked up at homes because of the COVID-19 pandemic. And I remember a situation where a good friend of mine, who was a facility manager in London, had samples that were really important to look at in the context of COVID and also future grant funding. However, there was no way to spend time at the facility. So the facility manager loaded the sample onto the microscope during his 1 hour of exercise that was allowed to UK population that time. Basically, people were able to get out of home just for 1 hour in a day to exercise, right? So some of us like to run, other people prefer to swap samples at TEMs. That's how that was done. And I remember looking at that sample, working remotely, and then suddenly my broadband connection was cut off because apparently all of my neighbors were doing exactly the same thing, working remotely, and the IT infrastructure was not ready for this. And then I remember calling my friend and saying that there is a crossover on this fluorescent screen. So basically, there is an electron beam welding through the fluorescent screen to get to the camera. And could he do something about it? Because I was locked up close to Oxford, 100 miles away, and there was no way to get to the machine in time. That situation actually highlights that, you know, being able to get to a microscope remotely is one thing, but we also need tools that allow us to check the status of the instrument remotely and also to control the instrument. We don't need access to all of the options, because certainly no one is going to apply, you know, aberration-free image shift while driving. That should not be allowed. But things like blank the beam or close the valve, stuff like this. So these emergency functions that you know, that could make life easier. And that situation actually inspired a lot of work, a lot of development work that was done later in order to develop the tools that I'm going to discuss today. So before we move on, I think we all need to understand that you know, that COVID scenario is now done and dusted. Hopefully, it's going to stay in the past. Hopefully, this situation is not going to come back. But if it does, then biology research facilities will be involved in fighting another pandemic. So, we've got to use the experience that we already got and build on it to be ready for whatever the future may hold next. Home working is here to stay. This applies to all science business. We see this in the industry. People are not coming back to work for 5 days per week, 8 hours per day. Some work is expected to be done remotely. This is also important in the global warming context, in the climate change context, where we really need to consider whether we want to travel, whether we have to travel every day to achieve certain goals. This is not going away. Many people would like it to go away, but we don't see this actually happening, at least not as fast as certain governments may want it to happen. So we're getting questions from our customers on whether JEOL could offer training sessions, whether JEOL could explain how to control our machines while working from home. With low-end systems, this is quite easy. With our higher-end systems, such as the cryo-arm, this becomes more difficult because while we can analyze a sample while working from home, we cannot refill liquid nitrogen, for example. So if we have a cryo sample with a cryo-viewer, we either need a refill system or a dedicated person, being present at the facility, topping up viewers. And that's something that requires a hardware solution rather than a software solution. So let's start with the daily routine. Let's start with the way of working remotely that people use most commonly. Let me first consider or explain the network topology. So I would like you guys to understand that the microscope is just one single giant computer, and in fact there is an embedded computer locked inside the microscope. This computer is not easily accessible. In fact, you never log into it. You are never logging into it. Service engineers do it occasionally when they have a particular service need. This computer communicates with the JEOL PC, with the JEOL computer that is being provided with the microscope. And for many of you, the only experience of using a computer with a TEM is just this JEOL PC. This is the machine on which TemCenter is being run. So you can, turn on the beam or open the beam valve. If you have a camera linked directly to the microscope, you can see the JEOL camera on this computer. It does allow you to control every aspect of the microscope operation. How does it do it? It connects via a separate interface to the computer that is being run inside the microscope. So considering the scope of today's webinar, I am not going to discuss the computer inside the microscope. We just need to know that there is a board there. It's an embedded system, and our JEOL PC, our JEOL machine, communicates with this embedded system. In the case of a very simple setup like JEM 1400, this is the only computer that you may be using in your facility with this particular microscope. However, if your machine is a higher end microscope like the JEOL F200 or 2200 or a cryo-arm, neo-arm or grand arm, you are highly likely to have one more PC available in your facility, and this is the camera PC. This is the computer that controls the camera. If you have a Gatan camera, this is going to be the computer that runs digital micrograph. If you have a DE camera, then this is the computer that runs DE server. In the case of TVIPS cameras, this is the computer that runs EM tools, EM menu, or Amplify, so the dedicated TVIPS software. In addition to that, you may add another computer. I called it here a support PC, and you can connect this computer to the same network where the JEOL computer is located, so they could all communicate. Why would you do that? For example, to provide external internet connectivity to your local microscope network. JEOL does not allow users to connect our JEOL computer to the internet. So it may never happen that you just plug a cable connected to the internet to a JEOL PC. This is done for a reason. Our JEOL PC normally runs on Windows, and we don't want Windows to call home and ask Microsoft to provide updates. That was possible some time ago, but right now with Microsoft releasing updates every week, it's just impossible for JEOL to test the updated version for compatibility with our microscopes. That would never work. That's why we say this is the reason why we say clearly that the JEOL PC should not be connected to the internet. However, it may be connected, it may be a part of a local network, and one of the other computers, for example, the camera PC or the support PC, could be connected to the wider internet. This normally depends on the amount of funding available. So if people can get a support PC, they normally want one. It also depends on the local IT regulations. So obviously, either the university IT department or a company IT department or IT security designated person has to configure and allow this internet access. And this is something that we cannot overcome. So in practice, if you want to access your microscope remotely, you will have to ask your IT department to allow either the camera PC or the support PC to be able to connect to the internet. This would also require opening certain ports on the firewall, and people who are responsible for IT tickets, they normally know very well what needs to be done in order to grant internet access. The bottom line is that we want to connect to the internet either the camera PC or the support PC. The support PC can be very small. It can be just a laptop with 2 network cards. Now, if your IT department is not that cooperative, there are other ways to solve the problem. This is not something that I personally or we as JEOL encourage in any way. But I remember solutions where a customer wanted to plug in a GSM adapter with a SIM card into a support PC to bypass the departmental IT regulations. That was not encouraged and it didn't end well. I'm just mentioning that this sort of solution is also available, but please make sure that you don't compromise the network integrity and the network security of your facility by doing this. So the best strategy here is always to talk to your local IT department, to your network administrator, and ask them to grant internet access to the camera or the support PC. Just as a technical note, the IP address of the local network is usually 172.17.41. something else, another number. Normally .1 is the Jeol PC and .2 is the camera PC, but you can add more computers into this network. The goal is to be able to connect to the support PC or the camera PC from the global internet. You may want to use a VPN client provided by your local IT department. This is the case for many universities, which provide an additional piece of software to students and staff. This so-called VPN client allows staff to connect to the university network in a secure way from any other place on the planet. This is very useful, and this is actually always the preferred way to go because it's secure. VPN clients normally provide 256-bit encryption, which is industry standard, and it means that no one can break into the connection or into the target PC, and also the users are authorized users who actually should be using the network or connecting to a given network. The scenario that we want to create is one in which the support PC or the camera PC acts as a bridge. So you can log in to this support PC remotely, and from that PC, you can then access the microscope computer or the camera computer or your local data storage PC or workstation, or any other workstation that you may be using in this context. For example, people who are interested in single particle analysis or electron tomography will normally have access to a computational resource, either a cluster or a powerful workstation that allow them to process data. Again, to get there, the first thing that has to happen is you normally need to log into the support PC. And this is the one that has to be accessible. It has to be exposed to the wider internet. From the Jeol point of view, as long as the Jeol PC is not connected to the internet, there are no issues. So we do allow it. We allow our customers to connect in the way that I'm going to explain here to the Jeol PC. This is not going to invalidate the warranty, and there should be no issues related to service support and so on and so on. Right. So what kind of clients can we use to get to the support PC? Right, so in order to get to the Jeol PC, we will be using the Microsoft Remote Desktop client provided by Microsoft. This is something that the Jeol PC supports. So once we log into the support PC, we can then use Microsoft Remote Desktop to log into the Jeol PC. So you see how does the support PC work as the man in the middle, so to say. The remote desktop, Microsoft Remote Desktop, has clients available for Windows. They are built in, but they also provide clients for OS X and Linux. In the case of OS X, you need to download the Microsoft Remote Desktop client from Apple Store. In the case of Linux, you've got to use a package manager to get it and install it on your system. Microsoft Remote Desktop is quite easy to use. All you need is the IP address. Theoretically, you could also use Microsoft Remote Desktop to log in from the wider internet to the support PC. This is not something we encourage because it's not that secure. Normally, computers that have public and static IP addresses do not have the remote desktop login option available because people can use a very simple brute force attack, basically keep logging and sending different combinations of usernames and passwords and eventually get into that machine. It's now in 2024, computers are fast, networks are fast. It would not take that long to compromise a computer exposed like this. So normally this is not encouraged. The industry standard that we are using inside Jeol and we also promote to our clients is TeamViewer. And just to say, we do not have any kind of agreement with TeamViewer to support them. It's just after COVID and after working remotely for many, many months, we found TeamViewer to be one of the most reliable tools that do the job. It also has clients available for the three major platforms, Windows, OS X, and Linux. It also has a client available for Android and another one available for iOS. So in principle, you could use your mobile phone to control the support PC remotely. It's not very convenient. However, it works, and it happened to me at least 2 times that I can recall, where it actually saved my skin because I was able to log in remotely to a customer PC on my mobile phone with TeamViewer. When it comes to security, it offers the industry standard 2-factor authentication, which basically means that you must have an authenticator app either on your mobile phone, iOS mobile phone or Android mobile phone. It does use your fingerprint scan or it does use face recognition in order to allow the login. So in this case, any brute force attack will not work because someone would need to physically get access to your mobile phone, which is way more difficult for a potential hacker. So as far as we are concerned as Jeol, TeamViewer is secure, and we have not had any of our customers ever questioning the security of the solution. The problem with TeamViewer is that it does require a paid-for license. It's not free. We as Jeol, we do have access for TeamViewer and we do have a commercial license for it. However, we are not allowed to share it with customers. We can use it for service and application support purposes, but we cannot give it to users. So in this case, the pricing is something that you would need to consider yourselves. A free alternative is called VNC. This one is also secure. It's open source. Everyone can download the source code, audit it, and then compile the executable to run it on their system. Clients are available for Windows, Mac, and Linux. So again, this is not a problem. However, I've got to say that it is way more difficult to set up a VNC connection than it is with TeamViewer. You really need to set up your local certification authority. You have to register it. You have to generate certificates for the server, for the client. If all of this sounds like a black magic, then VNC is probably not the solution that you're looking for. However, if you know a bit about computers and you're quite familiar with working in the console and with reading documentation, then VNC is a valuable piece of software that can do exactly the same stuff that TeamViewer does, with the exception of being freely available to everyone who is interested. Right. Another point is which sort of software should we use if we want to train people? So from the facility manager perspective, imagine you've got a cohort of 20 or 30 undergraduate students and you want to show them how does a transmission electron microscope work. Which software packages could you use to do that? And again, this is based on my experience with all 4 of these. You know, different platforms have different scopes and also pricing models. There are options that are good for really small meetings where people remain quite interactive. In this case, Zoom is a really nice option, and you also have the ability to use Zoom for free, providing that you don't exceed 100 participants and the meeting is no longer than, I think, 50 minutes, 50 or 60 minutes right now. So if you've got, you know, a small group of people, you just want to share the screen, maybe share a web camera, and just show how does the machine work, then Zoom is the way to go. GoToMeeting, the platform that we're using, is an overkill in this context. GoToMeeting is great if you want to organize a webinar for hundreds of people, where you have attendees, where you have organizers, and you really want to you know, control and structure the webinar. In these scenarios, GoToMeeting is great. But for these smaller meetings that should be just easy and where you need a client that doesn't go into your way, then probably Zoom is a bit better. Teams, this can do the same that Zoom does. Just again, from a subjective personal experience, Teams is slower, Zoom is faster. And then if you're a fan of Google, then Google Meet also does the job, and you can use it for 1 hour for free. So there is no reason to spend money. So this is just a summary that I would like people to remember. If you want to create a training session, a webinar, or you just have a class and you want to share your screen, then probably Zoom, Teams, maybe Google Meets if you're already deeply embedded in the Google ecosystem. The good thing about Microsoft Teams is that it's a part of the Office 365 subscription plan, which means that if your university subscribes to Office 365, then you already have Teams and you don't really need to pay for it. You just need to download it and use it. It also integrates nice with Microsoft Outlook Calendar, so you can schedule meetings, invite participants, and also ask them to send automatically emails with confirmation. So if you're deeply embedded in the Microsoft ecosystem, probably Teams is the way to go. Right, so let me show you how to access a transmission electron microscope using TeamViewer and remote desktop. For that, I'm going to use a microscope that is physically located in London, in the center of London, and as you can see, this is using TeamViewer. So using TeamViewer from my personal PC, I logged in into the camera PC on that system. I am physically located in Krakow, which is probably 1,000 miles away from London, but I hope the experience will still be quite smooth. So what we're looking at now this is the camera PC. In this case, this is GATAN. We can see digital micrograph running here. The camera is GATAN K3, and the microscope is JEOL CryoArm 200. So I used TeamViewer to get to my camera PC. In order to get to my microscope PC, I can use a remote desktop. And look what is happening now and how does the connection work. I've got TeamViewer, so this is my PowerPoint, it's my personal PC in the background. Then now I maximized my TeamViewer accessing the camera PC, and from the camera PC I use remote desktop connection to get to the JEOL PC. As I mentioned before, typically by default the IP of the JEOL machine is 172.17.41.1. The username is going to be exactly the same that you're using with your JEOL computer. This is either JEM administrator or JEM user, but it's possible that your system is configured to include more users who have access to the microscope. So this is going to be dependent on the exact particular configuration of your JEOL computer. Sometimes it may happen that it doesn't work as expected. In that case, you've got to go to the remote desktop settings on the JEOL computer, and when this loads here, you have to make sure that remote desktop has been enabled. So enable remote desktop should be set to on. Also, sometimes your local IT managers will give you some additional information about how to configure this connection. However, normally by default, the only thing that you've got to do on the JEOL PC is to enable remote desktop here. When this is done, you should be able to log in to the JEOL PC using the remote desktop client. We talk here about Windows systems. If your support PC runs on a Mac or on Linux, then basically you will need to have the IP address of your JEOL computer, and you will have to provide the username, often in the same way as you can see it written here, so domain/username. But this information should be provided by the local IT support. Now I am already connected, so let's get here. This is a CryoArm, so it's equipped with a cold FEG. The first thing that I want to do is to flush the FEG. I will use high flushing because that's the first time we're doing it today. And then I would like to start the emission. So let's give the microscope about half a minute to increase the A1 and A2 values, so the gun starts displaying some emission current. As you can see, despite me being 1,000 miles away, the system looks quite responsive. It does look quite interactive, and we should be able to do some work with it. Obviously, it's not as convenient as if you were, as it would be if you were sitting, next to the microscope. But certainly, it's usable. It's usable. We can use it for routine work. In this case, this is a CryoArm, so this microscope is equipped with an autoloader. which also means that the facility manager can load up to 12 samples on Monday and then stay at home for the rest of the week working remotely with the machine, because the refill, liquid nitrogen refill, is managed automatically. There is no reason to be in the lab. You can equally stay at home. So here, let me open the beam valve and maybe unblank the beam, and let's see whether we can see the beam. Yes, indeed, we can see a beam here. This is a live image. We can see cross-grating replica here, and the beam is live. Right. Let me close any logs here. Usually, when the connection quality is not that great, what you can do is make this live view as small as possible. This means that the amount of information that has to go through the connection is lower, and the proper compression may kick in and basically make the experience more smooth. But saying this, TemCenter is fully adapted for remote work. I do not have any panels at home. Here on the left-hand side, I've got a diagram of the microscope. I can change the magnification, for example. If I want to zoom out, I can just click here on the magnification selector. If I want to spread the beam, I also have the option to hover mouse over illumination and change the condenser lens free settings, maybe to spread the beam as required. If I wanted to move the beam, TemCenter gives me access to this lens deflector panel. And this does require some knowledge about how an electron microscope works, but it's not rocket science. At the very basic level, the only thing that you really need to know is that your beam align 1 deflector is responsible for the beam shift. The others, you don't really need to care about them. Beam shift is beam align 1. And you see, if I hover mouse over beam align 1, this small window appears. And here I can change the values on the X and Y by clicking on these arrows. This changes the excitation of the deflector coils and allows me to shift the beam. So basically, this is the equivalent of using the top knobs on the control panels. If I want to shift the beam, I can do it just by hovering mouse over my beam align 1 deflector and then using these arrows. It's not very convenient, but it's doable. And we've got people working like that. And the same applies to apertures. For example, if I want to change the aperture for a smaller one, condenser aperture, I can select a different aperture size, and this also moves the aperture as required. So TemCenter is interactive, and it does allow you to operate the machine remotely as usual, as if you were based physically in the facility. Saying this, we've got people telling us, we've got customers telling us that using of these arrows is not necessarily the best idea because, it may require you to do quite a lot of clicking. Also, older TemCenter, the older versions of TemCenter were not that interactive, and we were asked whether we could come up with a solution that could allow people to, control microscope in a more intuitive way. This is why we developed a piece of software called Virtual TemCon. So let me first discuss a little bit about Virtual TemCon. When you look at it, Virtual TemCon resembles the control panels. It's divided into two halves. On the left-hand side, we've got all the expected knobs. So we've got brightness, alpha, and spot. On the right-hand side, we've got focus, and we've got switches responsible for the modes, so low mag, mag, diffraction. We also have the top knobs and the bottom knobs. Here in this image, the top knobs have been assigned into beam shift as usual. The bottom knobs have not been assigned yet. Virtual TemCon works with all Jeol microscopes, and it's distributed as an executable exe file, so the installation is really simple. It does connect to the microscope using its own interface, the Tem external interface, and it makes certain things, certain operations easier. And also, if you are familiar with the control panels, it should be really easy to find functions that are available in Virtual TemCon. So let me show how this works in practice. When it comes to brightness, maybe let's focus on the brightness knob. This is the big knob on the left-hand side. I can hover mouse over the brightness knob, and I can use my mouse wheel to control the value of the CL3 lens. I can also change the step size. This horizontal scroll bar here sets the step size for brightness. So let's say that we use a little bit higher step size, and then I hover mouse over the brightness knob, and I use my mouse button, my mouse wheel to condense or spread the beam. So this is much easier than going into the illumination menu and then selecting step and clicking on arrows. Here, the step can be configured more smoothly, and it's normally easier to use the mouse wheel rather than do click, 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 click. Same goes for moving the beam, for moving around. Virtual TemCon is equipped with a feature called Control Pad. This opens when I click on Virtual Control Pad here, and a new window opens. And here with this window, I can use left mouse click and basically drag the beam in the direction where I want it to move. So right now I'm trying to go to the right-hand side, and we can indeed see that the beam moves to the right. If I want to go back, I just use my mouse to drag the beam back. So using your mouse is way more intuitive than clicking on these arrows, and Virtual TemCon can allow, or does allow, us to do actions, to execute actions faster. It does provide control over the microscope, also over the bottom knobs. So for example, if I want to use image shift, I can select image shift here on the panel, and then image shift is being assigned to the bottom knobs. And with the bottom knobs, I can equally use the knobs as I would with the panel. So for example, I'm applying image shift right now by hovering mouse over the bottom left knob. And as you can see, this shifts the image and the beam. So it does not replace STEM Center, but it makes using the microscope remotely easier. We can also use it to control the filter, the omega filter. If the microscope is equipped with a filter, we can use it to control the apertures. We can use it to control the stage. And we can also use it to execute some actions on the cryo-arm. I'm not going to discuss the cryo-arm specific functions today because that's out of scope of the webinar. Just one more feature that I want to focus on, it's called a fail-safe. Fail-safe was developed to prevent a scenario like the one discussed before, where you work remotely and suddenly your internet connection is being cut off for any reason. Here in fail-safe, you can specify the number of hours, for example, let's say 1 hour, when certain emergency actions are going to be executed. For example, close the column valve. If I now click on execute, we will see a countdown, and after this countdown gets to 0, Virtual TemCon will execute this emergency action here. In this case, it will close the column valve. Now, because Virtual TemCon runs on the support PC, if your remote connection is cut off, Virtual TemCon will still run, and it will still execute this action, providing you with the peace of mind that the welding beam is not digging a hole in your fluorescent screen or is not exposing your camera. This should be used as an emergency, and normally when I log in remotely and I've got some work to do, the first thing that I do is I set the fail-safe, then I minimize Virtual TemCon, and I continue working, I continue doing whatever I've got to do. Just to make sure that, in the case of emergency, no one has to run to the facility in order to make the system safe. Right, so let me maybe get back to my presentation here. Virtual TemCon can be installed on any JEOL microscope. It does integrate with serial EM. So if you use serial EM, you will have the benefit of having access to additional commands. For people who script, you will have access to vacuum information or nitrogen information. This is it does provide some extra value and extra scripting abilities that you normally don't get. Regarding fail-safe, you can close the column valve, you can set the beam off for thermionic machines, you can put the screen down, you can switch off the HT for thermionic microscopes, switch off the emission for cold FEC machines, and you can also trigger liquid nitrogen refill for cryo-arms. These actions can be executed as fail-safes. Right, I'm going to skip through single particle functions. I just want to highlight one more feature that's possible with Virtual TemCon. If you have a touch screen, then you can use Virtual Control Pad with your touch screen and move the electron beam with your finger. This is quite cool. I always show it to people because I think it's a new, innovative way that allows us to control microscopes. So if you don't have physical panels at home with a way to forward the connection to the microscope, virtual TemCon may replace quite a lot of the functionality. And if you open TeamViewer and use virtual TemCon with something like an iPad or an Android tablet, you can also use the touch functionality to control the beam position. Virtual TemCon can be used with any Jeol microscope that is available, that is out there. Regarding the cost, please get in touch with your local Jeol salesperson, because this will differ from an area to area. Tem external is required, so your system may require an update and an overall update to TemCenter before you can use virtual TemCon. Right. Another cool stuff that I want to talk about is called TemReporter. TemReporter was developed using the virtual TemCon experience and by trying to port this experience to a mobile phone. The disadvantage of virtual TemCon or TeamViewer is that you've got to log in, you've got to find the right options, you've got to spend time on doing this. Could we provide a solution that would be faster, that allows you just to open an app on your mobile device and it directly connects to your microscope and you can see all the details and you can still execute some emergency actions? In the past, that was in the domain of science fiction and fantasy, but right now this is possible. As Jeol, we came up with a mobile app called TemReporter. It was developed locally by Jeol Europe, so it comes from Europe, not from Japan. And it is supported by Jeol Europe, which means that for the European and UK and German folk, you know, the support is in the same time zone and it's quite responsive. Right now, this is available for iOS. We plan Android support to be introduced later in 2025. However, if you have an iOS device, for example, an iPhone or an iPad or a Mac equipped with one of the new M series processors, then you can download TemReporter and ask Jeol to install the client on your microscope. This will allow you to see the microscope and to control the microscope directly from your mobile. A lot of work was done in the background to make sure that TemReporter works smoothly with any firewall or IT restriction that a local IT department may want to enforce. We use ports that are commonly used for communications, TCP port 80, standard TCP communication, encryption where required, and basically, you know, with a little bit of goodwill from the local IT support, we should be able to make it to work with every microscope out there. Right, so let me show you how this works. The first thing that happens after you open it is that you've got to log in, and then it gives you a selection of microscopes that are assigned to your account, because you may have more than one. However, if you've got just one microscope at your facility that is connected to the TemReporter service, all you've got to do here is to click on continue. And what does TemReporter show is the basic status of the microscope. So basically the HT, quite important for thermionic instruments and also important for FEGs, because if the HT is 0, you can probably guess that you've got a power cut at your facility. You've got information about lenses and deflectors. You've got information about the gun and the HT. So things like A1, A2 emission current, all of this is available. Also, you can switch the HT on or off remotely from here and change the HT target. Imagine being stuck on a tube or a tram, and you're going to your facility. You may want to switch on the HT and start increasing it remotely. So when you access the facility, when you finally get there, the microscope is ready to work. In the case of field emission machines, we may open and close the V1. We can switch on and turn off the emissions, and we can flush the cold FEG. Again, you may want to flush the FEG and execute auto emission on while on your way to the facility. We can also blank the beam and unblank the beam and put the screen up or down. This is to protect the camera. Here, the idea was to keep the camera safe. We can read out the vacuum. Sadly, not all values are forwarded to TemReporter. We are working on it, but right now, at least it can give you an idea whether the vacuum was crushed or whether the vacuum is still there. For cryo-arms, you can get an idea about the liquid nitrogen level in the stage tank and the transfer tank, and execute a refill as required on one or both tanks. It also gives you access to the cryo-arm inventory, just so you know which samples are currently loaded into the microscope. You may forget, or you don't know what your coworker did or colleague did. You can quickly check what's going on with the machine. Also, information about the stage. This is mainly used for diagnostic purposes, whether the stage reached its limits. We also have graphs, so we can plot changes in the system. For example, here, changes in the liquid nitrogen level. We can see how fast the level of liquid nitrogen changes, and from that we can calculate the refill interval. Again, we can then copy this graph and put it into an email or send to a service engineer or use for any other purpose. TemReporter can also notify us automatically about certain events. So, for example, if the liquid nitrogen level is below a certain percent, or the HT is not at the expected value, or the emission current is below a certain value, you may get the push notification. Your phone and your Apple Watch, if you have one, is going to do ding, and then it will say that, for example, emission current is below the threshold, which allows you to be more reactive rather than log in and check. This TemReporter takes you into a scenario where you are notified and the system works for you actively, and you are the passive side. You are notified when something happens. You don't need to actively log in with TeamViewer, use remote desktop, check the correct parameter. But if something happens, you are notified quickly, and this allows you to take an action. Reporter is now available. We've got it working on some microscopes. If you want access to this technology, please drop me an email, and also please get in touch with your local service and applications support. As I mentioned, for Android, this will come to Android eventually, but it will be in 2025. So if you want to play with it or test it, help us and provide feedback about this service, then please do get in touch, but you will need an iOS device. Right, so just before the coffee break, let me show you TemReporter in action. I'm going to use a TeamViewer to connect here to an iPhone emulator. So we've got TemReporter installed as an application, and then all I've got to do is to open it. providing my emulator still works correctly, because unfortunately I cannot join with my mobile phone and share my mobile phone screen. This is not allowed. Hello again after the coffee break. Right, so let me first show you a very quick demonstration of what TemReporter can do for you. And for that, I'm going to share my screen again. Here we go. And I am going, so what you're seeing here is the TeamViewer connection to the real microscope. So we've got, if I open the V1, we should see the beam here. Here we go. And we've got TemReporter connected to the same microscope in real time. Here in TemReporter, I can swipe to the GAN and HT, and for example, click on Close V1. If I do it, as you can see, the V1 valve on the microscope was closed. So this is just an example of an action that can be executed remotely on a real microscope using the TemReporter app. Right. So let's resume with the next chapter, with the last chapter planned for today, and this is entitled PyJEM. So what is PyJEM and why we should care about it? PyJEM is a module that can be used with the Python programming language. Python is a high-level interpreted programming language commonly used in scientific research. If you process a lot of data, it's highly likely that you have already worked with Python and used other modules like NumPy, SciPy, and so on. Jeol created PyJEM to enable you to control electron microscopes using a Python interpreter. What it does is that it establishes a connection with the microscope and gives users access to all lenses, deflectors, and the complete electron optics system. If you use serial EM and you are familiar with serial EM scripts, PyJEM offers a similar functionality, but highly expanded. What serial EM allows is only a small subset of functions available in PyJEM. PyJEM exposes the almost complete interface to the users, giving access to control the microscope and write scripts that will control the microscope. When to use PyJEM? Well, this depends on your background. If you are a scientist working at a university, you may have expectations or requests to develop new software packages. A quick biological context, imagine a histopathology sample, a thin section, and you want to quickly calculate the number of cells trapped in that particular section. How to do it? Well, obviously you can ask an external provider, you can ask a PhD student, but then what these people are going to do? If they are not experts in computer science, then it's highly likely that they will use Python to develop a software package that does exactly this. Why? Because it's easy. Python is one of the easiest programming languages that people can learn. It's highly logical. The vocabulary is very close to normal native English language, and it doesn't necessarily use really advanced pointers advanced concepts such as pointers or direct memory management, which is a nightmare for proper IT professionals. So for a person who is new to computer programming or to computer science, Python is a really nice choice as the first language to start with. That's why we as Jeol, we decided to support this approach based on Python, and we decided to introduce PyJEM as our module, as our contribution to Python. If you are an industrial developer, if your background is pharmaceutical manufacturing, quality control, things or areas where you require the same routine to be executed again and again on the microscope, for example, for validation purposes, or as mentioned before, for quality control purposes, then you may want to write a Python script that will act as a recipe. And then you will force the microscope to execute the same script to follow the same recipe every bloody time. Again, in these scenarios, PyJEM is your friend. It's a tool that was created for you. Now, for people who know a little bit about Python, this is an example of a PyJEM script. So in this case, we import two modules from PyJEM. One is called TemFree, and it connects to the microscope. The other one is called Detector, and it connects to the camera. Then we've got to create objects that are responsible for certain things. So, for example, stage object that will be responsible for stage control. We could also imagine lens object responsible for the lenses, or a deflector object that provides connectivity with the deflectors. Then in this simple script, basically all it does is it sets the tilt angle to 10 degrees, and then it asks the camera to take a snapshot, save it as a JPEG in the folder that we specified here. So a very simple script, but you know, it just gives you the idea. Now, if you're completely new to computer programming, this may sound like black magic. I agree. In this case, you would need to sign up for one of the Python courses that are now very frequently offered by university IT departments for staff and postgraduate students. It's the beginning of a new academic year, so it's the right time to look for them. If you already did some work with Python, then a simple script like that should sound familiar. Right, where do we get documentation about PyJEM, about what we can do with it? PyJEM does have a repository on GitHub, and this is the address. It also has the manual that is available online, and if we go to this manual, as I do now, you can actually see what's included. And if we go to the TemFree module, this is the one responsible for microscope control. You will see that there are commands responsible for all aspects of microscope operation. For example, apertures, get kind of aperture, get size of the aperture, even get the state of your faceplate if you have a faceplate instead of the condenser aperture. If I scroll a little bit down, we've got the DEF3 module, which is responsible for the deflectors control. Filter lens alignment, condenser lens astigmatism, condenser lens alignment 1, which is in principle beam shift, beam blanker, all of the stuff that you may want to use. Then we've got quite a lot on the scanning deflectors. So if you plan to use this for STEM, this is also possible. Electron optics system, so brightness, alpha angle, selectors, spot size, probe mode, function mode. This is also included. You can change the electron optics system settings using PyJEM. Okay, I'm not going to discuss all of them, but in principle, if you want to use PyJEM, then the manual, which is available online, is quite extensive and should be sufficient to come up with your first scripts. PyJEM also provides connectivity with cameras. So in the case of the detector package, this includes the fluorescent screen camera. If you can see the fluorescent screen in TemCenter, it's also possible to see it with PyJEM. It also includes connectivity with the Site X cameras, the newer ones at least, and also with the EDS systems, but only Jeol EDS. So you must have a piece of software called Femtus, which is distributed with newer microscopes. If you run Femtus, then you can get with PyJEM also to the EDS data. Right, and live demo. So just to give you an example of what PyJEM is and what does it do for you. PyJEM is normally installed on the Jeol PC, and every single microscope that was shipped from the factory after 2019 should have PyJEM installed. And if this is not the case, please get in touch with the service or applications department, and they will be able to install it for you. Right. To check whether PyJEM is installed in your system, you've got to open the command prompt, then start the Python interpreter, just basically by typing Python. And then when the interpreter opens, you can try to import the TEM3 module. So from PyJEM, sorry, the speed is not my friend today. From PyJEM, import TEM3. And then we may want to create, for example, a deflectors object. So let's call it defl. This equals TEM3 def3, and the names of the classes are specified in the manual. So in principle, I'm just showing quickly how to establish the connection. But you can get information about other modules in the manual, and you can connect to other aspects, for example, the lens system, stage, filter, and so on. And let's say that we want to read the beam shift settings. So I have to execute the again, I have to execute the get CLA1 function on the deflector module. Let's say x, y equals defl get CLA1. Okay, and then if I have a look at the hexadecimal value of x, it says 01D3. And this is exactly the same as we can see in the lens deflector table. if I want to change the beam shift, all I've got to do is I've got to use the set CLA1 command, and in this case I can set it to 0x maybe 8123, and then again 123. And then if I execute this command, you can see that my beam aligned, so my beam shift now changed to these values. So this is a very short demonstration showing how to use PyJEM. Remember that PyJEM runs on the Jeol PC. So in the context of remote work, and maybe another fail-safe scenario, you can come up with a PyJEM script that will do something for you after a given amount of time. So for example, here I can import the time module. And then I can say that, for example, time now equals time dot time. This will store the number of seconds now in the time now value. And then I can use a while function. And I can say while time now no, I think I will not type it because the connection speed doesn't allow me to type directly. What I'm going to do instead is I will try to use copy and paste, which will be faster. So I'm just going to copy a script from the PowerPoint slide, and I will put it into a Python script on the Jeol computer, which is exactly something that you guys could want to do. Test script.py, and then let me edit it and let me paste the script here. What the script does is it checks the time now, and it allows us to specify a number of seconds that has to pass in order to execute a certain action. In this case, the action is set beam valve 0, so basically close the V1, close the valve. This will be executed after 1 hour from the moment the script is started. So something as simple as this. Now, all I've got to do is to change the name, change the extension of the script and run it to show you what's going to happen. Test. Let me. It's not a text document, so Windows in its great wisdom assigns the txt extension by default. And what I need to do is use cmd and then get to the Jeol directory. And then I need to rename this text document into a Python script, so basically change the extension to .py, and then I can use Python test script.py, and hopefully, if I press enter now, it should, of course, it should execute the script. Just a second. I need to change just one thing here. So fag should be all capitals. Okay, and as we can see, the script established communication with the microscope, and it now started counting. So with every second, we see 1 second increase. When this gets to 3,600 seconds, Python will close the V1 for us. Again, if it happened that my internet connection drops, is cut off for any reason, I may calm down knowing that after less than 1 hour, PyJEM will close the valve for me. PyJEM is available for free for all new machines, as I mentioned. It should be installed by default on any Jeol microscope shipped after 2019. Our applications and service people have the ability to install it or deploy it on any other computer connected to the microscope network. So for example, if you wanted to get PyJEM running on your support PC or your camera PC, please do get in touch. We may be able to do this for you. Right, so I think that's all what I wanted to say. If you have any questions, please, this is the time to ask them. Thank you.
Thank you very much, Bart. So yeah, as Bart said, this is the opportunity now to ask any questions on any of the topics that Bart has covered today, be it the use of TeamViewer to control the microscope or remote desktop inside TeamViewer, or the virtual TemCon software that Bart talked about, or TemReporter from your iOS device, be it your iPad or your iPhone, or getting messages on your Apple Watch, or the use of PyJEM at all as well. So feel free to put your hand up or to ask questions by typing in the questions text box. So whilst you're thinking up your question here, I'll ask Bart a couple of questions. So Bart, with the TemReporter software, what needs to go on the microscope in terms of software? Obviously, you've got the software on your iPhone, but what do we need to do on the microscope side?
Right, so in order to make TemReporter running on your microscope, you need a client, a dedicated client. This is a piece of software that we provide. Basically, it's a small executable that, well, let me show my screen actually again. So we are back at the K3 camera, so Gatan PC, and you do see a small client called Jeol Reporter Service or JEM Reporter Service. That's interesting. I changed resolutions here, so yeah, now it rendered correctly. So basically, this is a small piece of software that has to run on the computer that is connected to both the microscope and the external internet. And what it does is it uses the local network to connect to the microscope and discover its state, normally in 15 minutes intervals, but we may adjust it as required. And then it forwards the state of the microscope to an external server. Also, this is the tool that is responsible for the execution of emergency actions. So if you go to TemReporter app and let's say you click a button like I don't know, beam off, for example, or HT off, or close V1, then this command is being forwarded to this reporter service client, and then it executes it on the microscope. And there is not so much configuration involved here, so basically our service guys are able to deploy this within maybe 10-15 minutes, including testing.
Okay. Thanks, Martin. We received a question through the text box, the questions text box, and it's asking about the possibility of controlling or using Python to control our SEMs.
Right, so that's a different product called PyJEM. It is indeed possible to control our SEMs in the same way, but to be honest, that would require a dedicated webinar that would focus on scanning electron microscopes in particular. The context is exactly the same. It's a Python module that works with the Python interpreter. You've got to import it, and then you have options available like selecting the right scan rate, taking a picture, switching between the focus, the record modes. So this is possible for the SEMs. For sure, for the new SEMs that are currently available to purchase from JEOL. For older machines like 6610LV, for example, getting it to work could be a challenge, but anything newer, the IT series, yeah, that should be not a problem.
Excellent. So just give the audience some more chance to come up with any questions that they might have. I was wondering if you could say something about your interaction with Serial EM with virtual TemCon as well, Bart, because that's obviously an important part of how we operate with JEOL cryo microscopes.
Yeah, so as I mentioned during my presentation, Serial EM provides commands that are only a small subset of what's possible with TemExternal, and virtual TemCon can bridge this gap. Let me show you how. Does it do it. So getting back to TeamViewer here, I've got Serial EM. I've got Serial EM running, and I also have here virtual TemCon running. Virtual TemCon does provide access to a server, a TCP server. All you've got to do is to specify the IP address of the machine on which virtual TemCon is running. In this case, this is the Gatan camera PC, and then we start the server. What we can do next, maybe let me close Serial EM and reopen it again, because, yeah, maybe this one. And let's give it a chance to load. What Serial EM provides is a script command called run in shell. Run in shell can be used to open external applications. For example, run in shell notepad. If I run it, Serial EM will launch notepad. In this case, yeah, here we go. You see it opened. Maybe not everyone saw that. So let's again, if I close it, yeah, here we go. We've got notepad running. As a part of virtual TemCon, we do provide a small tool that is called VTC call. This normally lives in C JEOL VTC call. This is an executable that connects to virtual TemCon. Sorry. And how to use it? So we need to use the command prompt, and we need to get there. So maybe cd Jeol, cd VTC call, and then we can use VTC call, and we can, for example, say report time, if I type it correctly. This executes a command on virtual TemCon. You see, it received report time command, and then in the virtual TemCon directory, there should be quite a lot of junk, but we will also see a report time output, and we can see the current time of the support PC, right? So knowing that, we can now go to our scripts, and I just need to find an empty script if possible. Yeah, this one's good. And let's imagine that I do here exactly what I did here in the command line. So I use report time, run in shell, then I say c Jeol VTC call, c Jeol VTC call, and then VTC call exa report time, and then I maybe give it a delay of, let's say, 1 second so it can process it, and then I can read text file and create maybe a variable called time, and then this is in this directory, and the file is called report time output.txt, and then I can echo the time now is $time. And if I didn't make any mistake here with typos, you can see that the time now is basically this. This is an example showing you how to integrate serial EM with virtual TemCon. And virtual TemCon does provide control like PyJEM with every deflector and every lens installed on the microscope. But the idea here is that you can use this information and mix this information with serial EM script. This is just a trivial example, but obviously you can build on it. You can do much more than this.
Thanks, Bart. I think we're all quiet from the audience, so I was going to take the chance to ask you, have you integrated, say, using PyJEM with different camera manufacturers on the TEM as well? I guess some are better than others at exposing their Python or providing a Python interface.
Yes, indeed. So when it comes to Jeol cameras and SiteX cameras, these are now fully integrated and fully supported in PyJEM. When it comes to external manufacturers, it's mixed news. So, for example, DE, which is one of the largest manufacturers of direct electron detectors, they do provide their own Python module that allows them to control their cameras with Python. So if you have both PyJEM and DE camera module, in principle, you can come up with a script that provides microscope control and image processing using images collected from the proper counting camera. This is possible, but we've got to count on external manufacturers. In the case of GATAM, this is not that simple. GATAM provides digital micrograph, and they use the COM object, the component object model, which is a Microsoft Windows technology to get data out of the camera. It would be interesting to hear what GATAM has to say about it. But in principle, there are no technical reasons why there should be no Gatan Python module. I guess it's just a question that someone has to make one. But it sounds technically, on the technical note, it sounds doable. Saying this, I'm not Gatan expert, so I don't want to speak for them. But yeah, with some cameras it's possible. With others it could be possible if there is enough, how to phrase it gently, encouragement.
Excellent. Yeah, I think we're all good, Bart. Then I don't see any burning questions arising from anybody. So yeah, I think we've probably reached the end. So thank you for a very comprehensive presentation of our remote operation and automation technologies.
Thank you, guys.
Thank you very much.
It was a pleasure. Thank you.